Programming languages are the unsung heroes of the digital age. They act as the bridge between human instructions and machine execution. These languages allow us to communicate with computers and build the software that powers our world. From simple websites to complex artificial intelligence algorithms, programming languages are the backbone of it all. Programming languages can be broadly categorized into two main types: compiled languages and interpreted languages. Understanding the differences between these two types is crucial for anyone looking to delve into the world of programming. Each type has its own strengths and weaknesses, making them suitable for different types of tasks. This essay will explore the key differences between compiled and scripting languages, shedding light on their inner workings and providing real-world examples of their applications. By the end, you'll have a solid understanding of these fundamental programming paradigms. Let's begin by examining the world of compiled languages. Compiled languages, as their name suggests, rely on a process called compilation to transform human-readable code into machine-executable instructions. This compilation process involves translating the entire source code into a lower-level language that the computer can directly understand and execute. Think of it as translating an entire book from English to Spanish before handing it to a Spanish speaker. Compiled languages are known for their efficiency and speed. Since the code is translated in advance, the execution time is generally faster. This is because the computer doesn't need to interpret the code line by line during runtime. Moreover, compiled languages often provide better performance optimization. The compiler, during the translation process, can identify opportunities to streamline the code and make it run more efficiently on the target hardware. Now, let's take a closer look at how the compilation process works. The compilation process transforms your source code into an executable program. At the heart of this process lies the compiler, a specialized program that acts as a language translator. The first stage is lexical analysis, breaking down the source code into tokens. Next, syntax analysis checks if the arrangement of tokens adheres to grammatical rules. Then, semantic analysis verifies the meaning and context of the code. Finally, code generation translates high-level code into machine instructions. This rigorous process contributes to the advantages of compiled languages. Section 4. Advantages of compiled languages. Compiled languages offer several advantages. Their speed and efficiency make them ideal for performance-critical software. First, faster execution. Compiled languages generally execute faster than interpreted languages. The code is pre-translated into machine code, eliminating runtime interpretation. Second, performance optimization. Compilers optimize code for hardware. This results in faster execution and better performance. Third, early error detection. Compilation includes rigorous error checking. This helps in identifying and fixing bugs before runtime. Lastly, platform specificity. Compiled languages produce OS-specific executables. This allows for greater control over hardware interaction. Section 5. Exploring scripting languages. While compiled languages excel in performance-critical applications, scripting languages offer a different set of advantages. They prioritize development speed and flexibility, making them suitable for tasks like web development, automation, and data analysis. Unlike compiled languages, scripting languages are interpreted rather than compiled. This means that the code is executed line by line during runtime, without the need for a separate compilation step. Think of it as reading and translating a book sentence by sentence instead of translating the entire book beforehand. This interpretation process makes scripting languages more flexible and easier to work with, especially for beginners. The code can be modified and executed on the fly, allowing for rapid prototyping and experimentation. Furthermore, scripting languages are often dynamically typed, meaning that you don't need to explicitly define the data type of a variable. The interpreter infers the data type at runtime, simplifying the coding process. Let's delve into the interpretation process to understand how scripting languages work. Section 6. Comparing compiled and scripting languages. To fully grasp the differences between compiled and scripting languages, let's compare them side by side across key aspects. Execution-compiled languages are compiled to machine code before execution, while scripting languages are interpreted line by line during runtime. Speed-compiled languages are generally faster due to pre-compilation, while scripting languages are generally slower due to interpretation overhead. Flexibility-compiled languages are less flexible, as changes require recompilation, whereas scripting languages are more flexible, allowing code to be modified on the fly. Error detection. Errors in compiled languages are caught during compilation, while errors in scripting languages are often caught during runtime. Platform dependence. Compiled languages are often platform-specific, while scripting languages are often platform-independent. Examples: compiled languages include C, C++, Java, and Go, whereas scripting languages include Python, JavaScript, Ruby, and PHP. This table highlights the trade-offs between the two types of languages. Compiled languages prioritize speed and efficiency, while scripting languages prioritize flexibility and ease of use. Now let's explore some real-world applications of both types of languages. Section 7. Choosing the right language for the job. The choice between a compiled language and a scripting language depends on the project's requirements. Compiled languages are ideal for performance-critical applications like operating systems and game development. Scripting languages are perfect for web development, automation, and data analysis. Their flexibility makes them great for prototyping and automating tasks. Understanding these differences helps developers choose the right tool and build efficient software.